What Chebychev has done for us is he created the formula that lets us know worst case scenarios in any distribution whatsoever. If you go out one standard deviations, as you can see by plugging in the one standard deviation, squaring it, subtracting, he doesn't guarantee that any data will be living within one standard deviation of the mean of any distribution that looks nice, neat, skewed, or is very unusual looking. For two standard deviations, Chebychev is guaranteeing us that there's a 75% amount of our data within two standard deviations of the mean. For three, it's 89%. 4 is 93.75, and 5 standard deviations plus or minus should give us 96% of our data no matter what our distribution looks like. So we are now going to test Chebychev against our current data set called state, remembering that our mean is 4.9. That is our x bar, and our standard deviation is equal to 0.98. I'm going to use these values and check the places of the data. So for the first one, I'm going to take 4.9 plus or minus 1 times the standard deviation. And if you do that in your calculator, you should get 3.92 as the unemployment rate to 5.88. I need to make sure I inbound this, and you'll see what I mean by that when we take a look at our data set. I want to find out where 3.92 is. All right, I'm at the beginning of my data set. 2.7 is outside. It's below 3.92. So is 3.1, 3.5, 3.6, 3.6. 3.9 is very close to 3.92, but it still is outside of that range. So I have to keep going past there. This number 4 is the first thing that is actually inside the range of 3.92 to 5.88. And it is position 8. So that is the number that I'm seeking, and that is the number that I will use. Going back to my data set. So it's position 8. It's 4%, but the position number is 8. Now I'm going to look up the 5.88, and that's going all the way down here. I don't want to be bigger than 5.88. So I could take 5.8, I can't take 6, and even if I look at this position number, it is position 42 that's giving me 5.88. And now if I go back to my worksheet, I know it is position number 42. It was a percentage of 5.8, I believe. The real numbers I'm interested in right now are 8 to 42. So now I need to know how many pieces of data actually live in position 8 to position 42. Well, if we subtract, it almost gets there, but we have to add 1 to make sure we're taking care of the positions properly. And if we do that, we end up with 35. So 35 out of 50 pieces of data are within one standard deviation. That's 70%. So we are better than what Chebychev would have predicted. I'm now going to do plus or minus 2 standard deviations, and we'll have to put those points or the arithmetic down here. 4.9 plus or minus 2 standard deviations, and that gives us 2.94 to an unemployment rate of 6.86. So I'll go look up those positions. 2.94. Well, let's do the 6.86 first because we're already up at this end of the data. I have 6.1, 2, 3, 4, 5, Oh, the 7 one's not going to work, so that's position number 48 that we see right here. And that's the number I will use for that. So this is position number 48. And I want to know what my first position is. Since I'm at the end of the data set, I'm just going to go around this way. 3.1 I believe will work because 3.1 is inside of 2.9. 2.7 isn't. So I'm using position 2. So I'm going from position 2 to position 48. And if we do 48 minus 2 plus 1, we do in fact get 47 out of 50 data points. And if we convert that into a decimal, then we have 94% of our data. Again, we are much better than Chebychev predicted. And finally, for 3 standard deviations, 4.9 plus or minus 3 times 0.98. That would give me an interest rate of 1.96. I'm sorry, not interest, an unemployment rate of 1.96 to 7.84. And if I look this up in my data set, 1.96, the lowest one I have is 2.7, so that's position 1. And the highest unemployment rate is 7.1, and that's also inside. So I have all of my positions from position 1 to position 50. How many data points are there if you count from 1 to 50? Well, I'll show you why the plus 1 thing works. That would give me 49, so I have to add the 1 back in. That's just a counting technique. That gives me all 50 out of 50 data points. That's 100% of my data, and that again is much better than Chebychev's prediction. So what can my conclusion be for this? My conclusion is that this distribution of state unemployment data is more compact than perhaps we expected. It far exceeds Chebychev rule. So it is better than most data sets as far as its symmetry. It's your turn now to analyze the DART data. The DART data, which is on the next screen of the slide notes, was compiled by taking the attempts at throwing a dart at a target in an amateur dart contest and then measuring how far away from the bullseye each attempt is. Check your answers with the answers online when you finish the DART data.